Welcome to our discussion on estimating and evaluating. Here's our one and only objective for this video, and that is to be able to find estimates. Now, you might think that finding estimates isn't a real important part of critical thinking, but it actually is. It's the idea of just having a sense of scope and a sense of scale. How big should something be? Is it on the right scale? You should be able to recognize when a number is off by a factor of 10, either 10 too big or 10 too small, to help you catch those easy mistakes of moving a decimal point. So being able to estimate what a number should be by rounding and things like that is a good skill to have. So to estimate, right, is we're just going to make an approximate calculation. We don't have to come up with a precise answer, and oftentimes it's going to mean rounding. So we can think of this as an educated guess. We always have to ask ourselves, how precise do we want to be? And we should always ask ourselves, if we're going to round, when we're going to round, how much we're going to round. And that all is kind of dictated by the numbers that we're dealing with. If we have really, really small numbers, then we shouldn't round a lot. If we have really large numbers, then larger rounding isn't such a big deal. All right, let's look at an example, and we'll work it using good old Polya's four-step process, where we're trying to plan a wedding reception for 100 people, and we want to estimate the cost of the reception, and that's all the information we're given. So try and keep it as real world as possible and figure out, what would you have to do? Well, we have to understand the problem. That's step one. So the problem is, how much is it going to cost? Well, we don't have any information other than we have 100 people. So we better start doing some work. So we develop a plan and we figure out, well, let's list all the things that go into a wedding reception. And if you don't already know that, well, then maybe do a Google search and figure out what entails a wedding reception so you can start coming up with prices for those. And then you're going to estimate those prices and figure it all out. So when you look online, you can see that there are kind of four basic parts to any wedding reception. There's the cost of the venue, there's the food, there's the decorations, and then there's entertainment. And of course, all that can be broken up into various subcategories, but those are the four basic categories. Now, since we're estimating here, we can use averages. So you could go out and you could maybe check the pricing of a few venues, a dozen venues, whatever you want. You can look for any published averages. I'm sure wedding magazines put out averages all the time. Bridal magazines say, hey, the average cost of a reception is this, or an average cost of a venue is that. You can use those types of things. One such report, the wedding report from 2011, said the average cost of a reception venue, just the venue alone, was $32.28. So do we leave it at $32.28? Do we leave it at $3,000? Do we leave it at $3,200? Do we leave it at $32.30, $32.50, right? I mean, you could round it to a bunch of different things just depending on how precise you want to be. Now, some things to keep in mind is, does the average cost of a venue mean just the venue, or does it also include food? Because some venues charge and they include the food. So just keep that in mind. But since we're not sure what's going to happen with our venue, we can then kind of break it up and see that several wedding sites give total cost averages in the range of $47.50. And again, because we're estimating, we don't want to get bogged down with specific numbers. We can just leave it as that kind of average. And then decorations, again, if you look around, you'll find averages reported in the range of 900. You could round that up to 1,000 if you think. You do some more research and you find out that having a DJ or a single musician costs anywhere from 300 to 700 on average. But if you want a full live band, that ranges anywhere from 900 to 1600. Now, if you know which route you're going, then obviously you would use the average of that range. But if you don't and it's still up in the air, then you could kind of average the two averages and then come up with an amount of 950. So this is kind of the math behind it, right? 300 was the low for a DJ, right? 700 was the high for the DJ. You average those out and $500 average for a DJ. If you do the same thing here, 900 and 1600, you add those together, you get 25. You take half of that, that's 1250, and then you could take the average of 1250 and 500, and that would be your average, right? So based on all these averages, and which way you want to go, DJ or the other one, it looks like these numbers, they went with the DJ because that's the 500. Venue, food, decor, entertainment comes out to 9378, which is a clunky number at best. So I'd round up to 9400, maybe even round up to 9500, or heck, maybe you want to just say it's 10,000. Give yourself a little buffer room and say, hey, if we can budget 10,000, we're probably in good shape. Now, rounding. Should we round to 9300, 9350, 9400, 9500, 1000, 9380, right? I mean, what's the right answer? Well, it all depends on the scope of the numbers and how precise you want to be. 9400 is a pretty good estimate because we had 9378. Rounding to the nearest 1000 gives you 9000. To me, 9,000 seems really wrong, right? That's off by a lot. $400 seems like a lot, but that's only because we're dealing in relatively small amounts. I mean, 9,000 is not anything to laugh at, but 400 in comparison to 9,000, that's kind of a large chunk of that 9,000. It's relatively large, right? It's a large percentage of the whole. So to round all the way down to 9,000 doesn't make sense. But if we had much larger numbers, rounding down to the nearest thousand might be fine. So that's when students ask, how much should I round? There's really no clear-cut answer. It's always kind of what's appropriate for your numbers. And so to further my point, if your estimate was up in the tens of thousands, let's say 32,378, which would round, if you went to the nearest 100, to 32,400, and then you decided, well, why don't we just round that to the nearest 1,000 and talk about 32,000? Taking away that $400 from 32,000 doesn't seem as drastic as taking $400 away from 9,000. So do you see what I'm saying? That rounding is all relative to the size of the numbers. Now, the nice thing is most math classes that you're in, if you have to do this for an actual question on a test or a quiz, it's going to tell you where to round. It's going to say round to the nearest 100 or round to the nearest 1,000. But we're talking real world sense, right? We want to be smart in the real world. And if you want to use these practices in your real life, then just use some common sense. All right, the last step, right, in Polya's 4-step process is to look back and make sure that we did everything correct, we didn't make any big mistakes, and everything seems feasible. And 9 to 10,000 seems pretty feasible. So we probably didn't make a big error, because some of the most common errors that human beings make are factors of 10. They drop a 0 or they add a 0. And so if your answer came back as 900 instead of 9,000, hopefully you'd go, that just doesn't sound right. I really don't think I can have a wedding reception for $900. And if it came back as $90,000, you think, okay, well, unless I'm one of the Kardashians or the Rockefellers, I'm probably not going to spend 90 grand on a wedding reception. So there's probably something wrong with my math. And that's another kind of good point about learning how to estimate, is getting this idea of the sense of how big something should be. That's a really good, important skill to have in the real world. All right, put your skills to the check. See if you can pause the video and give this a try and see if you can figure it out. All right, well, hopefully you figured out it's a pretty easy question, because if our first estimate was based on 100 people, and now we want to figure out what it is for 50 people, shouldn't the easiest thing be just to cut it in half? And if we want to do it for 200 people, shouldn't the easiest thing be just to double it? Yeah, that's exactly what we're doing. Because remember, these are estimates, so we're not trying to be horribly precise. All right, a second example. where we can use some deductive reasoning in our estimation. We've got a public university is expanding its campus by building a new math and computer science center. They want to estimate the cost of the new center by using the cost specifications of the most recently constructed building on campus. The previous classroom building had 20,000 square feet of assigned space with a construction cost of $6 million. The new center needs to contain 40,000 square feet of assigned space. So right off the bat, what would be the easiest estimate for how much it's going to cost? And I hope you're all thinking, well, twice the space should be twice the cost, and it should just be 12 million. Now, is that a logical conclusion to make? Well, only if we think building costs are linear, meaning if you build a building twice as big, it's going to cost twice as much. It's really not that simple, right? If you know anybody in the building industry, even tangentially in it, they'll tell you that it doesn't work that way. If you double a building cost, it doesn't necessarily, sorry, if you double a building size, it doesn't necessarily double the building cost. It all depends on how you double the size. Are you doubling the footprint, meaning that it's, the first building was one floor and now the second building is still one floor, so it's twice as big? Or are you keeping the same footprint and you're just putting a whole nother floor on top of it? So now it's going to be a two-story building. That's substantially less money than making the building twice as big, in one floor, because you don't have to pour as much concrete. You don't have to have these big, huge beams to span these large spaces. So it's a fine estimate, but it's not necessarily accurate for all instances. All right, our third and final example, estimation using graphs. And this is something that you actually have to do a lot in real life because you're always going to be presented with data in these silly graphs. These are the things that newspapers love to do, and they're horrible because they're horribly inaccurate, and you really do have to use a lot of estimating to kind of figure out what the heck they're doing. So this is a great example of a 2011 study of student graduation data by Complete College America showed that on average, students ended up taking significantly more credits than required to complete their college degree. And why do you think that is? Well, because a lot of students end up changing majors throughout the course of their study. And when you do that, oftentimes a lot of the stuff you've taken kind of becomes useless. It applies towards some of your non-degree credits, but if you've already taken other non-degree credits, you end up having a lot of extra credits that you just can't apply anywhere. So according to the graph, students graduating with a certificate are required to take 30 credit hours. To get an associate's degree, they should take 60, and a bachelor's, they should take 120. According to the numbers, each one of those books represents 5 excess credits, and the green books represent 5 needed credits. So the associate graph shows 79 total credits, and I don't know how you could look at those 4 books and realize that there are only 19 credits instead of 20, right? Each book should be 5. 5 times 4 is 20. So are you telling me that top book is not a complete book? That's why these graphs are silly and stupid, because they're not really precise. And the same goes for the other one. Again, there are 3 blue books there. So those 3 books should be 15 total credits, right? 3 times 5 is 15. But if you look at the numbers, they were supposed to take 120 and they actually took 136.5, which means they were 16 and a half credits over. I hate these graphs, but you get the idea. So if you wanted to estimate what was going on with the associates, you can see 1, 2, right? 3, 4, 5, 6. Looks like 6 total books. So 6 times 5 is 30. So I'm going to estimate that they took 60. Now, is that an accurate number? Who knows? Because as we saw from the graph, it could be off a little bit in any other direction, but it's a pretty good estimate. So we're going to say they took an extra 30. Now, if the average cost of a credit hour is $287 when trying to get a certificate, it's a pretty low price per credit, by the way, could we estimate the total cost for courses that students should pay for a certificate, and then estimate the cost for courses that students end up paying if they take the average number of credits for a certificate. So basically, they're poorly worded questions, but part B is saying, all right, if they only took what they needed to take, how much should they pay? And then part C is saying, if they did the average, meaning they took how many they had to take the 30, but then they also most likely took the extra 30, how much? Well, you could do 287 times 30 and know that that's roughly how much they should pay, and then 287 times 60 and know that's roughly how much they do pay. But unless you have a calculator or you're pretty good with math, 287 times something is not easy, so maybe you want to just round and say, it's pretty close to 300. Because even if I round to 290, that's still, it's easier to do 300, because 300 times 30 is easy. You know, that's just 9 with a bunch of zeros. So we know they should take 30 credits to complete. And if we compare everything, it looks like there was another 30 that they ended up taking. In reality, the number was 63.5, so you can see again the graph wasn't that great. If they take the 30 to get their degree and the cost is 287, but we round that to 300, we do 300 times 30, we get 9,000, so it should cost approximately 9,000 to get the certificate. But if they're a typical average student and they end up doing roughly 60 credits, then you double that and it's 18,000. All right, so makes the math a lot easier. So we know roughly 9,000 is your minimum, 18,000 should be your maximum kind of thing. All right, one last skill check. Give this one a try. Well, if you go back and look at the bachelor's degree one, obviously they tell us that on average they're taking an extra 17, but as we discussed, it really looks closer to 15. All right, hope this helped.